Good morning. We're working on solving equations with logarithms. This is one that we did last time we met. So let's review how to do something like this. Any ideas? What does our properties say that we do? Our log properties. Remember? Oh, so when they're adding, what do we do with the arguments? It's supposed to be a plus. We multiply, right? So we rewrite this log base 5 of x2. We should probably write 2x, right? Okay? Just so it's in the right order. You know how mathematicians are. Equals 3. If it's in logarithmic form, what should we try? Exponential form. How do we rewrite this in exponential form? 5 to what power? Third power equals 2x. Okay, so do we know what 5 to the third power is? Or could we figure it out pretty quickly? 125, excellent. Equals 2x. Now how do I solve for x? Divide by 2. Good. What's 125 divided by 2? 62.5. Now, one of the things we talked about last time we met was how do we decide if this is a reasonable answer? At this point in our knowledge, in our learning, how do we decide if this is a reasonable answer? Yeah, we plug it in. Okay? So, in our calculators, because we talked about this last time as well, right? We're going to put log base 5 of 62.5 plus log base 5 of 2 equals, I mean, we could just hit enter right there, right? Or we could say equals 3 and then see what it says. What's it say? True. That means what? This is the right answer, right? So at this point in our learning, we know we can say that's a reasonable answer because it's correct. Okay? Later on when we get to word problems, we're going to have to determine another way to talk about reasonable answer. Okay? We'll worry about them though. We'll worry about that then. Okay. So this is one of the kind of problems, I did put a couple of these on your homework tonight just to review these, just to make sure we have these because these are kind of important. Okay? But there are going to be several other types of problems on your homework I want you to be familiar with before we get there. Okay? So here's one of them. Log base 4 of 12x minus 9 equals log base 4 of 3x. So if we're using logic, how do you think we would solve this? Yeah, if the log of this has to equal the log of this, don't these two thises have to equal each other? Do we even have to do logarithms on this problem? No, we just have to know enough about logarithms that the arguments of the two logs with the same basis have to be the same, don't they? So I can just say 12x minus 9 equals 3x. And we've been solving problems like this since at least Algebra 1, if not before that, haven't we? So we subtract 12x from both sides, and we get negative 9 equals negative 9x. How do we solve that? Divide by negative 9. Good. X equals what? 1. Is this correct? Do we have to use our calculators? Or can we just plug it in? Back up here would be nice, right? What's 12 times 1? What's 12 minus 9? 3. What is 3 times 1? Does 3 equal 3? Then that's the right answer. Any questions about that? Okay, does everybody have a copy? Good. Let's look at this one. Here's a different kind of problem that you might see. We're still trying to just solve for x. Okay, we're still using logarithms. This says log base 5 of 25x squared equals 2. So, if it's already in logarithmic form, what should we try? Exponential form. What does this look like in exponential form? 5 to the second power equals the argument, right? 25x squared. Does anybody know what 5 squared is? Oh, excellent. 25 equals 25x squared. So, take me through the steps to solve for x. Divide both sides by 25. X squared equals... Can you tell me what people tell me the wrong answer is right here? Yeah, 0, right? We know that's the wrong answer, but people sometimes forget, because it's 25 and 25, they think maybe they're subtracting, right? When in fact we are dividing, so our answer is 1. Good. Okay, how do I solve for x from here? Good. Square root. You guys forget this every single time we do the problem. Thank you. X equals plus or minus 1. So now what I'm thinking is, I'm thinking about a problem that we did the other day where we got, I think actually for that problem we got a positive 10 and a negative 10. And we said, oh, the negative 10 is wrong. I don't even have to check it. You can't do that on this one? Why not? What were we solving for when we got that positive 10 and negative 10? Yeah, we were solving for the base. Are we solving for the base in this problem? No, we're solving for part of the argument. Are you allowed to have a positive or negative argument? Okay, but in this case, does that even really come into play? What are we doing with this x value? We're squaring it, aren't we? So, what's 1 squared? 1, right? What's 25 times 1? And if I rewrote this in exponential form, I'd get 5 squared equals 25. Is that right? So 1 works for sure. What about negative 1? What's negative 1 squared? Okay, I want to show you something. And even though I've said it over and over and over again, I'm going to say it again because some of you still need to hear it. And I don't mean that disrespectfully, even if it sounded that way. Okay? This is what I saw already today. Log base 5, they were putting it in their calculator to check it. Okay? Log base 5 of 25, whoa, not there. Log base 5 of 25 times negative 1 squared. Enter. I thought you just told me that it worked. You have to do that. Every single time you have to do that. If I'm squaring a negative number, the calculator is going to do order of operations. And order of operations says you take the number you're squaring and square it, and then multiply by the negative. But that's not what we mean. Uh-oh, what did I do? Oh, I put the parentheses in the wrong place. Sorry about that. Let me fix it. There. That's what it needs to look like. See how the negative 1 is in parentheses? Then we get 2. And is that what we're trying to find? Yeah, 2. Does that make sense? If you're squaring a negative number in your calculator, you've got to put that negative number in parentheses before you square it. Or it'll give you the wrong answer every time. It's not that it's giving you the wrong answer either, it's that you're asking the wrong question. Fair enough? Okay, so be real careful with that, please. So, what are my answers, or what is my answer for this problem? Both of them, right? Both of them are correct. I checked both of them. They both work. Any questions? Alright, here's what another problem will look like on your homework today. 5 to the x power equals 12. Do you know what power that we need? 5 to some power equals 12? No? Could you tell me what two numbers it's between? How do you know it's between 1 and 2? Yep, 5 to the first power is 5. 5 to the second power is 25. 12 is between 5 and 25, isn't it? Okay? And if you'll remember, we did some problems like this before, and I told you at that time, right now we're going to put between 1 and 2. I think we even said closer to 1, right? But at a later date, that won't be good enough. Well, guess what today is? The later date. Okay? So 5 to the x power equals 12. Well, on this problem, it was given to us in logarithmic form, and we chose to rewrite it in exponential form to see if that would help. How is this one given to us? Exponential form. Any ideas what you think we might try? How about logarithmic form? What does this look like in logarithmic form? Log base 5 of 12, good, equals, perfect, equals x. Oh my gosh, do you even know how easy that is now? Log base 5 of 12, enter, done. Now, so that there's no confusion, and so that we're all doing the same thing, for this week, we are going to round to the 10,000th place. How many place values is that? 10,000ths is 4, right? So I would get 1.54. Uh-oh. What is it? It's 396. So some people think it's that, right? But what did I ask you to round to? 4 places? Is that 4 places? So what do I need? A 0, right? For rounding to the 10,000th places, which means I need 4 places. Even if that 4th place is a 0, I need my 0 there. Fair enough? Okay? Now, here's what's interesting. Remember I told you that I worked on doing answer keys the other day? Except I forgot this calculator, and all I had was my phone. But I can still do this problem on my phone. Look right here. Log. Except it's log base 10. But we talked about that change of base formula, remember that? I taught you. I said you probably won't ever have to use this. Except I used it all day when I was making the answer key for the whole meeting. Okay? Because I remembered that it's log of the argument but divided by log of the base. So watch this. 12, it's 12, right? Yeah, 12 log, that's the log of 12, divided by 5 log. Enter. Oh my goodness. I can do this on my phone. If I remember how, right? If you remember how. Okay? But guys, that's it. Now we just have to check it. So in our calculator or on our phone, either way, we can say 5 raised to the 1.5440. Is that exactly 12? Is it okay though? Why? Because we rounded. Exactly. We rounded. So it's not going to be exactly 12, is it? Okay? Any questions about that? Did you think that was going to be as easy as when we started? Okay? So do one more for me, please. 3 to the 2x power equals 17. 3 to the 2x power equals 17. If it's in exponential form, what do I want to try? Logarithmic form. What does this look like in logarithmic form? Log base 3 of 17 equals, ooh, that's a little different, isn't it? When I put this in the calculator, that's not going to be my answer, is it? Okay. So, whoa. Sorry about that. So I'm going to do log base 3 of 17. And before I write down an answer, what am I going to do? Yeah, divide it by 2, right? I don't want any rounding errors. I could get rounding errors if I divide too quickly, if I start rounding stuff and then dividing. So what should my answer be? 1.2895. Any questions about that? So those are all samples of problems that will show up on your homework tonight. If you have any questions, please ask as we're working in class. Deal?